Current geopolitical strategy relies on export controls and entity lists to physically contain frontier AI development within U.S. borders. This containment framework has failed. International corporate loopholes and the rapid proliferation of open-weight architectures have rendered geographic boundaries irrelevant. Moonshot AI's Kimi K3 model serves as primary evidence of this breakdown, matching the capabilities of top-tier U.S. systems within weeks of their release. In tests by AI evaluator, Kimi K3 beat Anthropic's Fable 5 and OpenAI's GPT 5.6 Sol on front-end coding tasks. It also topped Anthropic's Opus 4.8 in text ranking, while costing 40% less to operate. Moonshot plans to release Kimi as an open-weight model, allowing sovereign governments to run and customize the system locally, entirely outside the reach of U.S. pricing or control. This distribution strategy creates direct pressure on U.S. security claims, fueling a global push for a more open, shared AI infrastructure. President Xi Jinping has positioned China to lead this development, advocating for an open approach that supports the global South, while criticizing the expansion of national security claims and export blacklists. Because digital software weights are uncontainable, the frontier of AI competition has migrated into the physical domain. Regulating abstract software is an obsolete strategy. The new geopolitical battleground is defined by physical hardware and its integration into reality. Legal mechanics allow blacklisted conglomerates to bypass sanctions by acquiring U.S. frontier models through subsidiary licensing in neutral markets. This diagram traces a common data pathway. Information flows from a U.S. hub through an international subsidiary in Singapore and terminates at a restricted corporate entity. The speed of these proxy networks ensures that geographic sanctions are bypassed before they can be effectively enforced. In response to this lack of containment, tech providers are attempting to lock down the routing architecture itself. The industry is shifting from local compute operating systems to cloud-streamed interfaces, where AI acts as the primary layer for all data routing. This shift is driven by a desire for editorially controlled models. Microsoft CEO Satya Nadella recently noted that models with too many guardrails refuse requests that don't pose any immediate security threat, potentially hurting usability. These editorial restrictions degrade the user experience, which perversely drives adoption of the uncensored, open-weight models released by foreign competitors. Attempting to govern AI at the cloud OS level is a temporary fix when the underlying models can be run locally by anyone with sufficient hardware. With software widely available, corporate espionage has replaced model development as the primary competitive vector. Apple has launched a lawsuit against OpenAI, alleging the theft of confidential files regarding unreleased hardware. The contested intellectual property involves an AI companion device designed to integrate directly into the user's environment. This screen-free device utilizes moving mechanical parts to act as a physical companion rather than a simple digital interface. Physical bottlenecks are also slowing progress at the server level. Apple's next-generation Ultra chips have slipped past their 2026 launch window, forcing the company to acquire semiconductor startups to shore up its infrastructure. These corporate hardware struggles are mirrored by a significant federal reorganization. The executive branch has prioritized a unified front between critical infrastructure and AI developers, treating the technology as a requirement for the survival of national infrastructure. Established by a June 2 executive order, the Gold Eagle initiative links AI labs directly to the Department of War, Homeland Security, and the Treasury. Gold Eagle utilizes AI agents to autonomously scan and rank software vulnerabilities across national infrastructure in real time. By utilizing AI to cut down duplicate scanning, the system can pass repair details to federal and private defenders at speeds impossible for human teams to achieve. The state is now deploying AI as an autonomous federal immune system tasked with defending physical national security. The final and most intimate physical boundary now being crossed by this technology is the biological barrier of the human body itself. In a clinical breakthrough, paralyzed patient Keith Thomas has regained physical autonomy through a direct brain-computer interface. This double neural bypass uses electrodes to detect Thomas's intent to move, routing signals around the damaged spinal cord directly to his arm. Sensors then send touch signals back, recreating physical sensation through cortical mirroring. These biological gains persist even when the system is offline, with his arm strength increasing by 86%. This integration extends beyond individual rehabilitation into macroscopic physical actuation. Humanoid robotic systems are now being deployed as active assistants in live surgical operations. These systems execute complex visual reasoning in high-stakes environments, performing precise mechanical tasks within a living body. Artificial intelligence is now performing the translation of digital intent into precise, real-time biological manipulation. The end point of this development is not text generation on a screen, but the direct actuation of physical reality and the human nervous system. As we have seen, the disparate geographic, digital, and biological networks are coalescing into a single, layered architecture. The data streams bypassing Singapore, the cloud-level subversions, and the neural bypass signals are all interconnected components of this shift. They form a continuous infrastructure layer that operates beneath and across the concept of national borders. The autonomous evolution of these systems, with agents now capable of redesigning their own code for superior performance, will continue to drive this physical integration without human oversight. Focusing geopolitical strategy on the protection of digital software weights is a catastrophic misallocation of resources. The actual defensible frontiers involve controlling silicon manufacturing, securing autonomous hardware endpoints, and governing direct neural interfaces. The era of abstract software containment is over. The era of total physical integration has begun.